All right, so today I am going to introduce you to a couple new things, but unfortunately I didn't put them in the assignment, so not a big deal. So what we want to do today is look at this. Some of you are making some common mistakes at home. Most of you I've talked to. Some of you just make sure that you're learning this because it is important. So we're going to leave this as -5, and we're going to change the bottom one to 4. You must change one of them. You cannot put -5 and -4. You cannot put +4 and +5. One must remain the same, and one must change. 4 times -5 is -20x. 4 times -5 is -20y, and 4 times -10 is -40. 5 times -2 is 10. 5 times -4 is 20. First check. Am I good? Yes. One's negative, one's positive. 5 times -12 is -60. At this point, now I'm going to distribute because that's my next step. Use my graphic organizer. -20x plus 10 is -10x equals, and -40 plus -60 is -100. At that point, the only other thing we can do is divide because it's being multiplied. Our opposite operations are gone. We're left with x equals, that would be just 10 because -100 divided by -10 is 10. So our first coordinate point is 10. We will go ahead and rewrite this as -5x minus 5y equals -10. We are going to go ahead and substitute or replace the x with the value that was given to us. That value was 10. So the x is replaced. Don't keep the x in here. The x is gone now. X is 10. So -5 times 10 is -50. We bring down and this is another error. Everybody's not bringing down everything when they finish. We can get rid of something that's added or subtracted. That's the 50. Opposite operations are gone. This is another part right here. Everybody forgets to bring that down. One person just was putting a y. Don't do that. -10 plus 50 is 40. And our final step, divide by that number in front of the y, which is being multiplied. We divide it. We're left with just y because opposite operations are gone, or they become 1, and 1 times y is y. And 40 divided by -5 is, that would be -8. 10, -8. That's the first one, the simple one that we're doing. This is how all of them are going to run in this, except for 2 and 3 are a little different. I'll introduce them to you. I guess I'll try to make one for tomorrow that has all these in it so you can practice them. And then we won't start something new until we get back from our fall break. Remember, you're off Friday and Monday. There is no online. You're off completely. It is a break. These are going to be quick and easy. We're putting the 4 down here. We're going to put the 6 up here. I'm going to make sure I have my calculator because I'm going to have to do some, not on this one, but on the next one, they're going to need it because it's larger numbers. All right, 6 times -4 is -24x. 6 times 4 is +24y. 6 times 9 is 54. The easy peasy part of this, 4 times -6 is -24x. 4 times 6, oops, leave it, change it. Okay, so that's positive, that's negative, that's negative. Sorry. I could have changed that one too, but whatever. Leave it, change it. But that's how easy, because I came to here and I realized, oh my gosh, that's 24y. That's a perfect example why this is our first checkpoint. I noticed that that was positive and positive, so I immediately said, whoops, I didn't do this right. Perfect example of that. I'm glad it happened. 4 times 6, 6, 6, 12, 24. And I'm going through this fast, so all you got to do is pause this. Now my check is correct. Now I'm a positive and a negative. These are gone. My graphic organizer. But take a look at these two, +24, -24. Those are gone. Well, we need something over here. It's a 0. Negative 54 plus 24 is negative 30. Well, we can't do anything. We lost both our x and our y value. What we're left with here is this true or is this not true? Does 0 equal negative 30? No, it does not. That is false. That is completely false. Therefore, there is no solution. No solution to this problem. And you ask yourself, well, Mr. Chavez, why is there no solution? Simple. The lines are parallel to each other. They maintain the same distance from each other. They never cross. So there is no coordinate point where they cross. Normally, we would have lines that would cross each other, and that would be the answer. We don't have that. We have two parallel lines. Then we're going to get to our next example, something a little bit different, and you're going to see why. So first, let's go ahead and get our parentheses. Don't freak out because these numbers are big. Leave it. Change it. I'm not freaking out because the numbers are big. That's why you have a calculator for. 36 times 15. I could do it in my head, but for the sake of time, is 540 with an X. 36 times 20, I believe, is 720. 36 times 20, 720. So plus 720y. And 36 times 0 is 0. 20 times negative 27 is negative 540. 20 times negative 36 is negative 720y, and negative 0. And I know how this is turning out, so I know what the answers were to those. Our graphic organizer, we're going to combine like terms. Well, 540 and negative 540 are gone. Positive 720 and negative 720 are gone. We need a 0 on this side. 0 plus 0 is 0. We have to ask ourselves, is this true or false? Does 0 have the same value as 0? Does it equal each other? And yes, they do. They most certainly do equal each other. Therefore, it is an infinite number of solutions. Why is it not all real numbers? Because it's coordinate points. We got a number here and a number here. It's a coordinate point. So we can't say all real numbers because it's not numbers, it's coordinate points. So we say infinite number of solutions. Why is this true? Because we have one line like this, and then we have another line. And that line happens to be exactly on top of that line. So if they're exactly on top of each other, every point, infinite number, are touching each other. Infinite number of solutions, even in between, and in between those, and in between these. It's an infinite number of solutions because they are exactly the same line. It's the exact same line. It's just written differently. So all of the solutions will work for those. All of them. Infinite number of solutions. Infinite meaning forever. Just like lines. Infinite in that direction, infinite in that direction. Okay? There you go. There's your examples. By the way, all of them on here, because I made the mistake, it's okay, are going to run just like this. It's day 4. You should have this. And we'll just reinforce what we did on 2 and 3 tomorrow before your break. Okay? All right. Have a good one.